Today, we're going to look at the last subtopic in Chapter 1, which is uniform electric field between two plates. So this is the answer for today's questions. Questions 1. Figure below shows two metal plates with an electric field of 750 volt per meter between the plates. The plates are separated at a distance 0.4 cm apart in vacuum. Questions A. Calculate the potential difference between the plates. B. If a point charge of positive 2 microcoulomb is released at point B, determine the charge in potential energy of the particles when it reaches the negative plate. To calculate the potential difference between plates, let us apply the equations for electric field between two parallel plates. So E equals to delta V over D. Rearrange the equations and substitute the values into the equations. You will then obtain delta V equals to 3.0 volt. To deduce the change in potential energy, let's apply the equations delta U equals to Q naught delta V. Substitute the values into the equations. You will then obtain delta U is equals to 6 times 10 to the power of negative 6 joule. Questions 2. The figure shows a section of the deflection system of a cathode ray oscilloscope. An electron traveling at a speed of 1.5 times 10 to the power of 7 meter per second enters the space between two parallel metal plates. The electric field between the plates is 4.0 times 10 to the power of 3 volt per meter. A. Sketch the path of the electron in between the plates and after emerging from the space between the plates. B. Determines the magnitude and the directions of the accelerations of the electron between the plates. In these questions, if you look at questions A, it is asking for the path in between and after emerging from the plates. Means that this electron, it will be able to travel through the plate. So this is the answer for questions A. If you look at this diagram, electron will be deflected towards the positive plate because there's an attractive force in between negative charge and positive plate. And if you look at the diagram again, when it comes to sketching the path of electron in between plates, the things that you need to take note is the shape of the path before it enters the plate, when it is in between the plate, and after emerging the plate. Before these electrons enter the plate, it is moving in a linear path. So from here, electron, before it enters the plate, this is a straight line. And then when it is in between the plate, then it will move in a parabolic path. So this is a curved line in between the plate. And then after emerging from the plate, once again it's going to move in a straight line. So this is a straight line. So that is the answer for questions A. Questions B. Determine the accelerations of the electron. Since now my object is moving with an acceleration, therefore I'm going to apply Newton's second law to solve this question. So summation F equals to ma. Now if you look at the equation, I'm just going to focus on y component. Why? Well, that is because the velocity is constant along the x component. So which means along the x component, the acceleration is equals to 0. So in this question, we are just going to focus on what happens along the vertical component. So expand the equations, you have electric force Fe equals to ma, because electric force is the force that causes the electron to accelerate along the y component. Expand the equations again. You will get Q naught E equals to MA. Rearrange the equations and substitute the values into the equations. So since you are dealing with electron, so Q naught here, you substitute with the values of electron, and this mass is the mass of electron. So mass of electron is equals to 9.11 times 10 to the power of negative 31. So the final answer A is equals to 7.034 times 10 to the power of 14 meter per second squared. Since you are looking at the acceleration, which is a vector, you need to state the direction. So according to the diagram in questions A, the electron is being deflected toward positive plate, which is upward. Therefore, A is going upward. That's all for today. I will see you again tomorrow.